Welcome to Basics Revisited at Pradian 1414. Today we master the wavy curve method, a powerful technique to solve rational inequalities without testing every interval separately. The wavy curve method, also called the sign scheme method, tells us exactly where a rational function is positive, negative, or zero. Positive means the curve is above the number line, negative means below, and zero means on the line. This lets us solve inequalities like f of x greater or equal to 0, visually and quickly. Here is our expression. We need to solve the fraction with numerator x minus 1 squared times x plus 2 divided by x minus 3 times x plus 1 squared, all greater or equal to 0. First, identify every factor. Each gives a critical point where the expression can change sign. Let us analyze the term x plus 2 raised to the power 1. Its critical point is x equals negative 2. Since the power is 1, which is odd, the curve will cross the number line at x equals negative 2. The sign changes as we pass through this point. The expression equals 0 here, so this point is included in the solution. Next, x minus 1 squared. Critical point is x equals 1. Power is 2, which is even, so the curve bounces back at x equals 1. The sign does not change here. The expression equals 0 at x equals 1, so it is also included in the solution. Now the denominator term x minus 3, power 1, critical point is x equals 3. Since it is in the denominator, the expression is undefined here, not 0. Power is odd, so the curve crosses. X equals 3 is excluded from the solution. We use an open bracket. Finally, x plus 1 squared in the denominator. Critical point is x equals negative 1. Power is 2, even, so the curve bounces. X equals negative 1 is also excluded because the denominator becomes 0 here. Sign stays the same on both sides. Now let us place all four critical points on the number line together. At x equals negative 2, odd pair crosses. At x equals negative 1, even pair bounces. At x equals 1, even pair bounces. At x equals 3, odd pair crosses. This is our complete sign chart foundation. Remember the key rule. Odd pair means the curve crosses the number line and the sign changes. Even pair means the curve bounces back and the sign stays the same. Step 3. Check the sign in the rightmost interval by substituting x equals 4. Numerator gives 9 times 6 equals 54. Denominator gives 1 times 25 equals 25. The result is positive, so in the region x greater than 3, the curve is above the number line. Now we draw leftward, crossing at odd points and bouncing at even points. Starting from the right, for x greater than 3 the function is positive, the curve is above the number line. Now at x equals 3, we have odd pair, so the curve crosses to below. Between x equals 1 and x equals 3, the curve is negative, below the line. At x equals 1, even pair the curve bounces, sign stays negative. Between x equals negative 1 and 1, still negative. At x equals negative 1, even pair, curve bounces still negative. Then between negative 2 and negative 1, still negative. At x equals negative 2, odd pair the curve crosses. For x less than negative 2, the function becomes positive. Between x equals negative 1 and 1, still negative. At x equals negative 1, even pair, curve bounces, still negative. Then between negative 2 and negative 1, still negative. At x equals negative 2, odd pair, the curve crosses. For x less than negative 2, the function becomes positive. Here is the complete solution. X belongs to negative infinity to negative 2, closed bracket, union with open bracket 3 to positive infinity. X equals negative 2 is included because the numerator is 0 there. X equals 3 is excluded because the denominator is 0 there. To summarize the 5 steps. Step 1. Find all critical points. Step 2. Identify odd versus even powers. Step 3. Mark them on the number line. Step 4. Check sign in the rightmost interval. Step 5. Draw the curve, crossing at odd pairs and bouncing at even powers. Always start from the rightmost interval and move leftward. Thank you so much for watching Basics Revisited at Pragan 1414. I hope the wavy curve method is now perfectly clear. If this video helped you, please like, subscribe, comment, and share. Hit the bell icon so you never miss a new lesson. Keep learning, and see you in the next video.